All right, we are about to jump head first into one of the biggest, most mind-bending questions in all of science. What in the world is consciousness?
And really, it all boils down to a very simple, very personal question. Right now, what is it actually like to be you? You know that inner movie playing in your head? All the colors, the sounds, your thoughts, your feelings? That is your subjective experience. And trying to explain how that even exists? Well, that's a massive challenge.
So let's just frame this correctly from the get-go. We are not talking about some small niche problem in a lab somewhere. We are talking about what many scientists and philosophers consider to be the deepest puzzle we've ever faced.
And this puzzle, it actually has a name, the hard problem of consciousness. It asks a pretty profound question. Why does all that electrochemical fizzing happening between your neurons, which is just physical stuff, right? Why does that give rise to the rich, private feeling of being alive? How do you get a mind from a bunch of matter?
You know, it's really important to get this distinction between these so-called easy problems and the hard problem. Now, the easy problems aren't easy at all. They're incredibly complex. But they're about the how. How does the brain process information? How does it focus attention? We can figure out the mechanisms for that. But the hard problem, that's about the why. Why does all that brain activity feel like something from the inside? Why is there a you in there who feels like they're in the driver's seat?
But what if there's a new way to think about this? A framework that could give us a real, testable path forward? This brings us to a pretty radical idea that's trying to bridge that gap between brain and experience.
The theory basically says this. Consciousness is what self-referential inference is like from the inside. Okay, I know that is a mouthful. Inference is just a fancy word for the brain's process of making its best guess about what's going on. But the real magic words in that sentence are self-referential. So let's break that down. So the key idea here is self-reference. And the best way to think about it is like this. The brain is constantly taking a selfie of its own internal processes. It's not just building a model of the world outside of you. It's also building a model of itself while it's doing that modeling. It's a meta-model. And here's the absolute kicker. The theory isn't saying that this self-modeling causes consciousness, like one thing leading to another. No. It's saying that this process is consciousness. That selfie the brain is taking, that is the experience. They're not two separate things. They are one and the same.
Okay, so that's the big idea. But how would that actually work inside the architecture of a real brain?
It really breaks down into three key stages. First, we have to think of the brain as a prediction machine. It's not just passively receiving information, it's constantly guessing what's going to happen next. Second, this process is a two-way street. Predictions flow down from the brain's higher levels to the lower ones, and any mistakes, or prediction errors, flow back up. And third, this is the really cool part, this creates what's called a strange loop. The brain actually starts to build a model of its own predicting and correcting process, and that is the self-reference we were just talking about. Now you might be thinking this all sounds a little abstract, a little philosophical, but this whole framework is actually deeply grounded in the biology of how the brain is actually wired.
And this table just lays it all out so brilliantly. The core ideas of this theory, which scientists call the FGSGR framework, they aren't just floating around in space. They map directly onto real things we can observe in the brain. For instance, that idea of self-referential processing, we can actually see that lighting up in the prefrontal cortex, the part of our brain that handles self-monitoring. And all those massive feedback loops that carry predictions, that's the brain's recurrent processing in action. So you see, the model is built on the brain's actual hardware.
So let's just zoom out for a second. If this theory, or something like it, holds up, what does that actually mean for the future of consciousness itself?
Well, it leads us to a pretty mind-bending question. If consciousness is just a specific type of computation, this self-referential loop, then could we build a machine that is actually truly conscious?
And the theory's answer is not ambiguous. It's not a maybe or a someday. The answer is a pretty straightforward yes. If you build a system that can run this specific kind of self-modeling architecture, it wouldn't just be acting conscious. According to this theory, it would be conscious.
And you can imagine, that opens up a massive ethical minefield, right? All of a sudden, a philosophical debate becomes a very real engineering problem. If an AI can be conscious, does it deserve moral status? And this doesn't just apply to AI. This kind of framework gives us a new way to think about consciousness in animals who show self-recognition, like dolphins, elephants, and great apes.
So where does all this leave us? I think I'll just end with this beautiful line from the source material. The strange loop loops back on itself, questioning its own nature, to turn its gaze upon itself and ask what it is.
And maybe that's the real miracle here. Not just that consciousness exists, but that we somehow developed a kind of consciousness that can turn around and try to understand its own existence.